at the same time equal to the value of the function, so the function is continuous at the origin. Okay? طيب تمام كلام جميل. Continuity in a set. In order to know if a function is continuous on a certain set, يكفي الديفينيشن اللي بقوله لك ده. It should be defined at every point through this set. يبقى انا عرفت الفانكشن ازاي تبقى continuous at a certain point. اعرف ازاي الفانكشن is continuous in an interval. It should be continuous at each point of this set of this interval. So once more, definition of f is continuous in a set A if A belongs to the domain and f is continuous at the point A for all A belongs to A. عارف كلمة for all A belongs to A دي يعني عند كل البوينتس اللي inside A. ماشي؟ Okay, so the domain of continuous functions, it's x belongs to D, where f is continuous at x equal to. F is continuous if it is continuous at all points in its domain, as I told you. The probabilities of continuous functions, these are the probabilities of continuous functions. They can be added together, the result will be continuous function. If you have two functions multiplied in each other, it's going to be continuous. If you have f of x over g of x, and g of x is avoiding x doesn't equal to 0, or g of x doesn't equal to 0, then it will be also defined and it will be continuous. Furthermore, for a vector valued function, what's the vector valued functions? If it is Rn into Rm, from Rn into Rm, so the output, لا الاوتبوت اكتر من function. دي اسمها vector valued function.
لا مثلا بتبقى x بعد كده x y او x y to x y z.
لا اللي هي بتبقى x و y تطلع two branches. يعني تطلع x سكوير بلس x و y بلس x. دي اسمها vector valued function. Okay. Furthermore, a vector valued function f such that df is Rm into plus Rm. يوم تبقى from 2 to 2, 2 to 3, 3 to 2, and so on. It's continuous if and only if its components are all continuous as you will see. Continuity of familiar functions, دول الفانكشنز دول احنا كلنا عارفينهم continuous. البولينوميالز، الانفروتس، الاكسبوننشالز، الارثماتكس، absolute values, trigonometric functions, those are all continuous functions. Just a second. By the usual operations, addition, subtraction, multiplication, division, composition, كلهم continuous. هي البوينتس اللي الفانكشن undefined أو بتتشينج its rule. طبعا for vector valued function it has to be بص الحركة دي برضه مكتوب عليها. If and only if all of its components are continuous. That's a very important remark, usually confusing. Once I give you a function, a vector valued function, to study its continuity, it's a little bit confusing because you have f1 and f2. It's going to be continuous if both of them are continuous. I'm sorry, اتفضل.
كنت عايز اللي هو بس اسال عن اي حاجه من الفانكشن دي ولا هي كونتينوس وانا عارف اصلا هي بتبقى انها كونتينوس. continuous through its domain. تكتب continuous through its domain. مش لازم بقى على
لا مش هتعمل ده. طالما هي continuous in its domain. بس افرض ان انا كان عندي function, a piecewise function which has a rational function, then another function, and is asking you to study the continuity at certain point. In this case, I will have to do it.
تمام.
طيب هنا بص على example. You will show that the function f of x و y are continuous away from the origin. ودي vector valued function. اشمعنى vector valued function؟ لأن الانبوت x y will output how many parts? Two of them. طيب how to be continuous away from the origin? We want you to show that it's continuous, that the function are continuous away from the origin. بعيد عن الاوريجن. وانت مش عارف الاوريجن. صح؟ طب يا ترى هي continuous away the origin؟ بص هكتبها ازاي؟ بص this function is a polynomial function, absolute function, roots فعلا. polynomial functions صح؟ absolute functions and roots. And their sums are continuous functions in the entire plan. The function fi, f1 of 2, as quotients of continuous functions are continuous in their domain of definition. That's for all points except at the origin. يبقى انت عايز تثبت انها continuous away from the origin, it is away from the origin. طيب if I want a deeper look, يعني لو انا بقى عايز ادرس عند الاوريجن اقدر ابص اكتر. هنا بيقول a deeper look to the function. The domain is all points except where denominator vanish. So f1 x squared over y divided by x squared plus absolute of y. This is defined except where the denominator is equal to 0. So at x equal to 0, y equal to 0. So at 0, f is not defined, the formula, but we can check the limit x y tends to 0. ما عنديش definition للفانكشن بس اقدر ادرس الليميت. معايا؟ اوكي، same way like لو انا عايز ادرس الليميت، بص لو عايز ادرس بقى الليميت بتاع دي اكس سكوير واي على اكس سكوير بلس ابسولوت واي، ما عنديش الفاليو بتاعت الليميت. انا عارف ان انا مش ديفايند. اوكي؟ ما اقدرش تعمل سبستيتيوشن بالدينومينيتور اللي هو 0 0. طيب علشان ادرس ده اعمل ايه؟ اضطر استخدم الدايركتد ميثود او الايتريتد ميثود علشان اجيب فاليو اتستد بالديفينيشن. وانا عارف ان الديفينيشن بتاع الليميتس مش بيوجد ليميت، بيتست فاليو اوف ا ليميت. يعني كل الديفينيشنز اللي انا استخدمتها كنت بقول لك ايه يا عمر؟ بقول لك find or show that the limit of كذا equal to كذا، صح؟ لكن لو انا بوجد الليميت الديفينيشن مش هيديها لك. امال مين اللي يديها لك؟ الدايركتد ميثود او الايتريتد ميثود. لو لقيت اكتر من برانش او اكتر من باص equal the same value. تعالى كده بص. If I want to do further investigation، طيب انا همسك بقى الفانكشن دي وهدرسها لما اكس بتساوي كام؟ 0. طب لو انا حطيت اكس بتساوي 0 يبقى لو اكس equal to 0 تشيل ده واي اكسس هيفضل عندك واي 0 في واي على 0 بلس واي which equal to 0. يبقى ده along x equal to 0. طب لو انا عملته along y equal to 0، لو جيت اعمل along y equal to 0 ده يبقى بزيرو ده يبقى بزيرو، يبقى برضه هتساوي 0. طب لو حبيت اعملها along y بيساوي x سكوير، هيبقى ده x سكوير ده x سكوير ده x سكوير ده x سكوير، يعني بيساوي كام؟ بص لو جيت استخدمه هيديلك x4 على x سكوير بلس x سكوير which is gonna be x سكوير over 2 which is 0 برضه. يبقى ده معناه ان انا ام سسبكتنج ان الليميت بتاع الفيرست برانش بيساوي كام؟ بيساوي 0. هاو تو بي شور بقى ان هو بيساوي 0؟ هيوز ديفينيشن. اوكي، يبقى once more اهو بص. So all approaches to the origin give 0. Let us use the definition to check if the limit exists or not. لو انت عايز تكمل. طيب بالنسبه للسكند برانش نفس الكلام، اهي دي الفانكشن بتاعتي اهو مش ديها جبت اكس سكوير جدا اكس سكوير واي سكوير. طيب اكس سكوير واي سكوير لو انا شلته اف ابسولوت واي از ايكوال تو 0 then اكس اكس سكوير بلس واي سكوير ليس ذان ايكوال تو دلتا which means epsilon سكوير ليس ذان ايكوال تو دلتا. so the function is defined by x equal to 0. طيب لو انا خدت السكند برانش همشي فيه نفس الكلام so if one is continuous everywhere. ده بالنسبه للبرانش الاولاني. انا بقى فيكتور فاليد فانكشن خدت الجزء الاول، لسه الجزء رقم مين؟ السكند كومبوننت اللي هي اكس واي على الروت بتاع اكس سكوير بلس واي سكوير. الاول استخدم الدايركتد ميثود عشان انتخب to elect a speculated value for the limit, then I will use the definition. So once more, I'll x at 0, then I will take y at 0 and then y equal to x. All of them led to 0. I've tried to use the definition and it is 2 epsilon over 2 less than or equal to delta. So once more, yes, f2 when x defined is 0. So f1 is continuous everywhere at this time. ماشي؟ طيب that's another problem. Explain why f of x is continuous away from the origin. I will leave it as a discussion. This problem also exists. طيب بص آخر حاجة في الجزء الأولاني الساعة كام دلوقتي؟
41
كام؟ 11 41. اوكي لسه قدامنا شويه. هنا بيقول define a function g is called an extension of f if the domain of g contains the domains of f and f of x equal to g of x for all points in d of f. The main purpose of this part is sometimes or maybe I will have function which is discontinuous at certain point. Why it is discontinuous at a certain point? Because the limit is not equal to the definition.
Okay.
طيب what if I have the freedom of putting the value of the function equal the limit? Then I can change it or extend the continuity at this for this function at this point. So once more, if the domain df of a continuous function f is not closed and the a is an accumulation point of them, then f limit x tends to f of x, for f of x equal b exists, hence there is a continuation or continuous extension G once you do this condition, as you can see. I believe if I took an example, it will be very nice. So if I go to this problem, you want to determine if the vector valued function can be extended by continuity. Sorry, just a second. If I want to show the extension, okay, ماشي, of this function at the origin. أنا بس كنت حاطط example تاني, just a second. Continuity. Yes. Data view. Just a second. دي الحته اللي انا كنت عايز اتكلم عنها. هنا بيقول consider the function h of x or y which is 4x squared minus y squared divided by 2x minus y when y doesn't equal to 2 of x, or k when y is equal to 2x. You want to find the value of k, make h a continuous function at 1 and 2. That's the definition of the extension of a function to be continuous. In order to do this, all I have to do is to find the limit. معايا عمر, is to find the limit of this function. Let's find the limit of this function and put it equal to k. So simply, if I want to solve this problem, all I have to do is to try to find the limit of the first branch. يعني بص, I will try to get the limit
of that first branch
of x tends to of the function when x and y tends to 1 and 2, which is 4x squared minus y squared divided by 2x minus 1, which once you substitute, it's gonna be 0 over 0. But if you remark, I can simplify it, getting x and y, okay, tends to 1 and 2. So I will make a factorization for the brackets, so it's gonna be 2 of x, this is y, that's y, positive, negative, and it's divided by 2x minus y. I will eliminate these two brackets together, then I will have the limit of x and y tends to 1 and 2 for 2x plus y, which is gonna come up to, I believe it's 5 or 4? 4? Oh, so this value, yes, this value is equal to 4. يبقى for this function to be continuous, عشان الفانكشن دي تبقى continuous, لازم الكي ده يساوي كام؟ يبقى هنا الديفينيشن اصبح بيساوي الليمت بالظبط. ماشي. Okay, so once more, here we go. So once more, remark that h is a continuous function at 1 and 2. If there exists the limit of h is equal to h1 and 2, all I have to do is to evaluate the function, then make the substitution so h is continuous at k is equal to 4. That's another problem for whether it is continuous function of f to a. You have f of xy, which is x minus 1, y minus 2, divided by x minus 1 squared plus y minus 2 at the point 1 and 2. In this case, in order to simplify your life, I can make a substitution of x minus 1 equal to u and y minus 2 equal to v. I can make a substitution. If I make this substitution, ya Omar, the limit will be coming to the origin instead of dealing with 1 and 2, and it will make a huge difference. So, that means, does the limit xy of f of x exist? So we can get back to testing around the origin. If I made this substitution, لو أنا عملت السبستيتيوشن ده يبقى أنا عندي الليمت بتاعت u و v tends to the origin of u dot v divided by u squared plus v squared. ده الديفينيشن ده اللي أنا هعمله دلوقتي. I'm using this guy, so that's the value of the function of u and v. So let's study the limit when u squared doesn't exist. In order to do this, I will use the directed method. So let's do when v is equal to 0. So if I use the v equal to 0, the value is equal to 0. So the value is equal to plus 2, take u equal to 0, which means it's equal to 0. bus 3v is equal to u. If I make v and u equal to each other, it's equal to f. This limit doesn't exist. ليه doesn't exist, Mr. Omar? لأن when we use u equal to v, the limit is equal to r. When you use equal to z, the limit is equal to 0. So I have two limits not equal to each other in two buses, so it doesn't exist as you can see. So since the limit doesn't exist, there is no continuous extension of f at this point. You will have some problems like this problem, which is exactly the same. I will do exactly the same steps. We can solve it later. But now I want to talk about the probabilities of continuous functions. As we saw previously, that if we have two functions which are continuous, if I have the addition, subtraction, or multiplication of a constant type of function, or the magnitude, or making the division, then the function is going to be continuous as long as you are avoiding the points of 0 of the denominator. That's a justification of this function to be continuous. Direct one. Here, a vector valued function of a vector variables Rn to Rm with m is greater than 1 is continuous at A if and only if its n component functions are all continuous, and we already mentioned this previously. That's another example on the same period. In order to justify it is continuous, I will have to justify it is continuous on both branches for this function. Study the continuity of f1 at 1 and negative 2, and so it is valid for the other function. Let f Rn into Rm, f is continuous, if and only f, each sequence of your function converges to A, formed by objects of f to f of x. So once more, if I have these points approaching a certain value, the function is approaching certain value for f of A, which means it is continuous, as you can see. The composition also, if I have two functions, I can get the composition as long as they are continuous and they can be working together, then the result will be a continuous function. So from Rn into Rm is continuous in a compact set of x, then f of x is also compact of Rm. If you see this function, this is from R2 into R, a compact set. What's the meaning of compactness? R, compact set, it means it satisfies how many conditions? Two conditions. Bounded and closed. So if I have the set closed and it is bounded, then it is compact. This condition is really very important to one of the most important theories that we will have. I will skip this problem for the time being. Okay, we want you to show that the composite function is continuous. It's very simple, and you already have it. I already sent it to you. But what I want to talk about right now is Carl Weierstrass theory, which is really very important. Carl Weierstrass theory explains that if you have on a compact set, so if f df from Rn into R, it is a continuous function and compact. So how many conditions ya Omar? 5 minutes of us. Okay? So this function, I can apply Weierstrass theory if I have the following condition. Number one, the function is continuous. Number two, it is a compact, your function is compact, which means it is closed and continuous. If I have this, then your function is going to have a maximum and a minimum through this set. But once more, if I have a function, it is continuous. رقم واحد continuous. Number two, the set is compact. يعني the set is compact, closed and bounded. Then for sure, this period will have a maximum and a minimum. That's the case, one of the examples, our continuous function, as you can see, and so it contains a maximum and a minimum. Or even for this function, it has a maximum value and a minimum value. Weierstrass theory cannot apply on this example. ليه Mr. Safe ما تقدرش to apply it on this example؟ لأنه simply it's not closed. These limits are not with you. So once more, A and B is not a compact set. We cannot apply the Weierstrass extreme value. طبعا بعد زي ما كاتب إنها is not compact. لأنه compacted means bounded and closed. Since it's not closed, خلاص يبقى ما ينفعش إن أنا أطبقها. برضه AB is if your function is not continuous, then Weierstrass theory cannot be applied. For this problem, as you can see here, you have discontinuity. صح? Then Weierstrass theory cannot be applied for this problem since it is not continuous. W is continuous in a compact set, so we can apply Weierstrass theory, which is, and all of these theories, this one, the theory, and the coming theory, they are initiations to the beginning of the optimality discussion that we will go through it later in chapter. Okay, that's a function in 2 by 2. As you can see, the domain is compact, which means bounded and closed, so I have a maximum and I have a minimum point. Are you with me? And of course it's a continuous function. خلاص اوكي عرفت ان ده لها local maximum. This is not continuous بالتالي ما ينفعش ان انا اطبق Weierstrass theory. هنا بيقول لك let f from R to R and CAB belongs to R with A less than B. Which of the following sentence is true? F has at least one global extreme point in C. The continuity of F in C forces the extents of global maximum and the global minimum of F composite F in C. This is the correct choice, I believe. So once more, that's the correct choice. I've wrote this example and I've solved it and also inserted the reasons for this quiz to be moving. طبعا الجزء ده زي ما قلت لك is not connected, so we can't apply Weierstrass theory on it. This is the last one, which is Bolzano intermediate value, which means if you have a function under it is continuous, blah 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 blah, then you can have an average for this value. And also insert an introduction for having a big value for a certain function, we will need it down there. So the statement is like this: f be a real function of real variable, continuous in A and B. Let k be a real number. If k is a real number, exists between f of A and f of B. There exists C, where the value of the function will equal to k. That's the mean value theory, or an introduction for this guy. Also, let f be a real function of real variable, continuous in A and B. F of A times f of B less than 0, then f has at least 1 0 in AB, which is one of the important theories that will help you in catching a zero of a certain function. Okay, once more, that's the function continuous and its images. Smooth if it is smooth transition, then we move from an interior point to the domain without any problems whatsoever. Okay, thank you very much for attending this lecture. Please try to go through it. I've already sent the PDF to you, so please try to resolve these problems. It's really very important. Thank you very much.